Thank you for joining us today. As you get settled, a few reminders. Please remember to be constructive in your comments and questions to the presenter and to one another to ensure that we have a session that is productive. Additionally, please do not use the chat box to ask any questions for today's panelist. Instead, use the Q&A. Brad will answer as many questions live as time will allow, and we'll answer any open questions offline to be sent in a follow-up email. And as always, the webinar content and additional resources will be available online shortly after the session. Today's webinar, which will focus on safety standards related to design, construction, and installation methods of automated vehicular access points, is brought to you by High Security. It qualifies for one AIA HSW learning unit for those who are watching live, which AIA California will report for you once you have finished the session in full. Now to introduce our presenter, Brad Richards, who holds the Certified Gate Operator Design Certification from the AFA, has been in the automated gate industry for over 15 years and has been a member of the High Security team since 2009. As a specification sales engineer with High Security, it is his focus to work with architects and engineers as a consultant. He assists with writing specifications for automated gate systems and provides design guidance for those systems to ensure that the project meets the client's needs while also conforming to the UL 325 and ASTM F2200 safety standards. So on to today's presentation. Brad, I know that your camera isn't working today, but we are going to be focused on the education side of things. Please take it away.
All right. Thank you, Rebecca. I appreciate that. Let me get this shared properly here.
Looks great.
Looks good. Okay. Hello, everybody. Welcome to How to Design a Safe and Compliant Automated Gate System. High Security is a division of NICE North America. We're a worldwide recognized industry leader in automated vehicular access. My role is to work with architects and engineers in the early design stage to help you write your specification, identify the proper equipment, and not only consult on our operators, but the entire perimeter security apparatus as well. So use me as your subject matter expert on any future projects you got coming up. And Rebecca already covered the AA requirements for this presentation, so they'll be taking care of that for you. This course is designed to train architects, engineers, and installers on the best practices for a safe and compliant automated gate system. So you'll learn to identify non-compliant gate systems, how to design for compliance with UL and ASTM safety standards, and of course, where to search for additional resources about these standards. And honestly, the best place probably to find that information, the most current information, is the back of our manuals. A lot of information today. Don't expect you guys to retain all of it. Certainly give me a call and let me know if you have any questions related to these standards. So anytime you automate a vehicular access point, UL 325 and ASTM F2200 safety standards come into play. Underwriter Laboratories generates the UL 325 standard, which covers the machine that moves the gate, whereas ASTM generates the F2200 standard, and that governs the construction of the gate and how all the parts and pieces integrate together such that you're not creating pinch points and hazards. And certainly these URLs are available to you guys. ASTM, of course, for the F2200 standard. In the DASMA.com, that stands for Door Access Systems Manufacturer Association. It's an umbrella organization that consists of multiple gate manufacturers, gate operator manufacturers. We are one of them. Get together twice a year and come up with updates to these standards. So back in 2018 in August, a couple things changed about this standard. So if you're familiar with it, some of these might be a surprise to you. It's required to define all types of gates in the entrapment zones, of course. The second bullet item is probably the the thing that most encapsulates this entire standard. Requires 2 independent means of monitored entrapment protection for each direction of travel, both open and closed for slide gates, but just one direction for swing gates. So the closed direction is only required to be protected on a swing gate unless there's an entrapment zone that exists in the open direction. We'll get into that in a little bit. Also requires us, the manufacturer, to provide a list of approved devices, and I'll be sending that information out. And it requires us to show entrapment zones and what those are and how to protect those in our manuals, of course. And just allows the use of jumpers, resistors, and switches to defeat monitoring. You'll hear from some out there that UL and ASTM standards are voluntary and don't carry the force of law. Nothing could really be further from the truth. Nevada became the first state to embrace them back in 2001, followed by Louisiana and Florida. And by 2014, we had more than 50% of the states and municipalities were including these standards in their building codes. So OSHA includes this as a compliance at the federal law. And this is also included in the International Building Code, IBC. So these standards definitely are not voluntary. The moving gate can cause serious injury or death. Believe it or not, these things do happen. A couple examples here. The one on the left, a young boy in Las Vegas, unfortunately lost his life on this system. Let me grab my pointer here. What happened, these kids would actually get in and out of the facility. This is an HOA facility. And they put this pad mounted swing gate here through the fence line. And these kids would actually crawl through this gap to get in and out of the facility. Well, one kid was crawling through there. The friend dropped his bike on the free exit loop, activated the gate, and unfortunately got him caught up in the gate system. So that could have been alleviated or mitigated by actually reducing this gap down to 2¼ inches. You're going to hear that measurement a lot throughout this presentation. That would have been compliant with the standard and would have prevented that issue. On the right here, up in Mukilteo, Washington, there was a young boy that unfortunately was walking by a slide gate that didn't have proper fallover protection. That gate fell over, hit him on the head, and unfortunately he perished from that as well. And just one more here, at Dickey Stadium, there was a janitor leaving work. You go through this gate system. We're not supposed to have pedestrians walking through a vehicle access point, but he was doing that. And he had 2 things that he did here that we could have mitigated. He was able to reach through the gate panel and operate the gate while doing so. So that access control should have been out about 6 feet. Really, the requirement is no closer than 6 feet, can certainly be further out. And the gate panel should have had proper coverage, bringing those gaps down to 2¼ inches up to 6 feet on the gate panel. Both those things were done, that would have mitigated that issue. So an automated vehicular access point is more than just a gate, it's a system. Right. So the system is going to include multiple external inherent safety devices such as access control, the gate, of course, gate operator, locking mechanisms, there's vehicle sensors, etc. So all those components are typically manufactured by separate companies. They need to work together seamlessly and provide the required security and throughput, of course, but really the biggest priority should be safety. So access control points, it can be hazardous to people, of course, that I've just mentioned, and also cause damage to vehicles if designed without adequate safety considerations. So as a specifier, you want to know how to specify the proper equipment and safety devices that result in a safe installation. So again, safety is really the most important design consideration here. Even for something like a nuclear power plant or a very high security facility like an airport or critical infrastructure, safety really needs to be at the top of that list. So again, UL 325 governs the machine that moves the gate along with the entrapment protection devices. It also calls out specific installation requirements like signage and placement of the safety devices. So UL listed operators that are typically tested by an independent laboratory. We use ETL. And they'll test the gate operator and accessories and certify that they meet UL 325 requirements. You notice that the first bullet item here calls out UL 325 as a voluntary listing and labeling program. While some manufacturers out there might bring a gate operator that's unlisted, unmarked to market, the liability of doing so is extremely high. So under most jurisdictions, if the site is inspected, the installer or end user will be informed the installation doesn't pass code and must be replaced with a UL listed and marked operator. So as I mentioned before, the most reliable resource, a place to find the most up-to-date version of the UL 225 is going to be the back of our manuals. And so that's really the best place to find it. So we offer a CSI formatted 3-part spec language for all of our operators. In this example, UL 325 is called out in a project spec. You want to specify the gate operator is UL listed and marked in your specification. You see here we called out that UL 325 standard listed by a nationally recognized testing laboratory. You also want to call out in your spec the qualification of workers. And I think one of the most important things is calling out the qualification of the installer. So our spec language calls out that you must have a minimum of 3 years experience installing similar equipment and have been to a factory training within the last 3 years. So listed and marked are obviously key specification terms. So the term UL 325 compliant can be self-declared by some manufacturers attempting to bypass the standard without going through the lengthy and expensive process of having their machines tested by a third-party laboratory like ETL. So you just want to make sure that you are specifying a UL listed and marked operator. You're looking for a sticker like this on the operator. You can see ETL is called out here, UL 325, and also the Canadian standard CSA is called out, which is their version of UL 225 up north. So UL calls out their classes in 4 distinct classes. Class 1 is up to 4 single-family residences. Class 2 is going to be more of a commercial environment, like an office park or multi-family environment. One important thing to note on the class 1 and 2 with a slide gate, class 1 and 2 have a speed limit of 1 foot per second on the slide gate operator only. When you get into class 3 and 4, there's unlimited speed limits. So there's operators that'll go as fast as 3 feet per second and carry as large as a 5,000-pound gate panel that quickly. You don't want to put something like that on a class 1 or 2. So class 1 and 2 are really characterized by general public access for the most part. Whereas when you get into class 3, that's going to be off the beaten path. This is going to be more characterized by people traversing this access point that have credentials, they have a card key, they're supposed to be there, as opposed to general public, right? And then class 4 is going to be your high security environment. So anything that is critical infrastructure, like this United Nations building is a good example of that. Airports, food, energy, anything that's considered high security would typically be class 4. This is where you're often going to find crash barriers as well as standard gate operators. So this chart comes right out of the UL 325 documentation. It's a good cheat sheet to kind of give you an idea of what safety devices need to be used for what type of gate operator. So in this case, let's say we're utilizing a horizontal slide gate. Come down here and you see the different types of safety devices offered. They label these as type A, B1, B2, C, and D. Type A is an inherent entrapment protection system, otherwise known as an IES, inherent entrapment sensor. So it's required by UL that anybody who wants to build a UL listed and marked operator needs to build into the operator an inherent entrapment sensor system. So that's the type A. So you remember I talked about the need to have 2 independent means of entrapment protection, protecting both open and closed direction. This type A inherent entrapment sensor that's built into the operator is your one means, your first means of entrapment protection. And then you're left to decide on your secondary means. So that's going to be either type B1, which is otherwise known as a photo eye, whereas type B2 is a contact sensor, otherwise known as a gate edge. So you can use either one or a combination of the two. We'll get into that in a bit here. And when it comes to swing gates, operators, as well as traffic control arms, pretty much the same thing. The only difference is instead of the type A, we're utilizing the type C, which is basically their swing gate or barrier arms version of the inherent trap sensor. It's basically a force limiting clutch that's built into the operator. And then you're left to decide on the secondary means of entrapment protection. And then the type D is what that is a continuous pressure button. So let's say you've got a guard at a prison. He has line of sight either through video or in person. He can see the operator, can see the gate moving, presses that button, the gate starts moving, lets go of the button, the gate stops. So it's full control over the gate with that button. And that would be considered a typical class 4 environment where they would use maybe this type D and then utilize the inherent trapment sensor that's built into the operator and the one before operate, and they're good to go. So the inherent trapment sensor or system operates differently depending on the type of gate operator that you're working with. The one on the left is a hydraulic style gate operator. And so what's going on there, there's going to be a hydraulic pressure sensor. And so when the gate hits an object, it's going to see a spike in pressure. Let's say that operator is running at 750 PSI normal operation. The installer might set that about 200 PSI above that. And when it sees that spike, it's going to stop and back up. Versely, an electromechanical operator, very much the same end result, but it's looking for a spike in current. When it hits an object, it sees a spike in current, it stops and backs up. And then we're talking about the type C, their version of the inherent trapment sensor for both barrier arms and swing gate operators. And that's going to be some kind of a force limiting clutch system built into the operator. Couple examples of those secondary means of entrapment protection. So the photo eye, what you see here is a good example of outdoor rated photo eye. This is a through beam photo eye. You can use either through beam or reflective style. The through beam is going to need to send power to both sides. It's going to send and receive on both sides. So you need to run conduit across the lane for a through beam photo eye. I recommend through beam photo eyes if you can, because they are more reliable than a reflective style. If you can't run conduit across the lane, you're going to have to actually use a reflective style. On the right here, you see an example of gate edges. So a gate edge, typically about 5 feet in length, is typically going to go on the leading and trailing edge of a slide gate. It can also be put on a swing gate. In the case of a swing gate, you're going to use what's called a rounded edge because that's going to activate in multiple directions as opposed to this style, which is going to be on the leading and trailing edge of a slide gate and activates only one direction. The way they work, pretty much like an elevator door, when it hits an object, presses that bumper, makes contact with the circuit, tells the operator if it hits something, stop and back up, right? And obviously photo eyes, they work just like if you have a garage door opener, you're familiar with that. You break the beam, stops the gate, backs it up. And this is a list of the approved UL 325 devices that will work with our gate operators. This can be also sent out, and every manufacturer is going to have a similar list. And so these have been tested through the third-party laboratory to work and are approved for UL 325 compliance. You can see we have photo eyes in both reflective and through beam style. You got the edges there. The edges can come in either a wireless or a hardwired version. The wireless, of course, is going to be out the leading and trailing edge of the gate, and they're going to have a transmitter that is communicating with a receiver inside the gate operator. Whereas the hardwired, of course, is going to go through a conduit up into the operator. And those hardwired, they're typically going to be used on static follower or guideposts. And we're going to get into when to use those in a sec here. So here's an example of utilizing photo eyes to protect both open and closed direction. As I mentioned, it's required on a slide gate to protect both directions. The old standard was just the closed direction. It's now required to protect both. And so in this case, they've got photo eyes covering the open, and then another set over here covering the closed. Plan view of that. Again, it was only used to be required to provide this photo eye set. It's now required to provide the open direction as well. Where to place these photo eyes, the recommended approach is about 5 inches off the face of the gate and between 21 and 27.5 inches off of grade, typically post mounted like you see in this photo. This is a suggestion, and there's a number of ways to do this, but that's to the typical location for these. In this case, they've used gate edges, so both leading and trailing edge to cover both open and closed direction. That is also compliant with the standard. So I talked about the different types of gate edges. You've got wireless at the leading and trailing edge, and you've got the hardwired here on the guideposts. When do you need to use these? Well, if there's an entrapment zone that exists between the gate panel and that guidepost, then it's required to either put some material in there to bring that gap down to 2¼ inches, which is compliant, and that would suffice. Or you could put a hardwired gate edge here, which of course is going to run through conduit up into the operator and terminate on the control board. And that's either one is going to accomplish the task here. Either one is going to be compliant. So if you have a little Johnny riding the gate, for instance, and he hits that gate edge, it's going to stop, back up, and not draw him into that entrapment zone. Well, things to know about gate edges. First of all, this photo is a great example of how not to install a gate edge. You would probably want to have this all the way down to the bottom of the gate, but these are typically about 5 feet in length. A couple of things to know: they must hit an object to work, whereas a photo eye does not. They use battery for the transmitters. Those batteries are typically going to last about 2 years and need replacement, and they're subject to climate wear, so they'll need to be replaced once they wear out. So another example here, in this case, we've got a commercial class 2 environment, which, as I mentioned before, is a 1 foot per second operator. You couldn't go any faster than 1 foot per second in this particular class. In this case, they've got the inherent entrapment sensor built in, and their secondary means of entrapment protection was chosen as photo eyes for both open and closed direction. This single family residence application is a class 1. And of course, has a 1 foot per second speed limit on the slide gate again. Inherent entrapment sensor built in, and then in this case, they've used gate edges at the leading and trailing edge of the gate panel to cover both open and closed direction. You can actually see the transmitter right here for the gate edge. So having said all of that, you can tell there's a number of combinations of ways to approach compliance. You could have a combination of gate edges and photo eyes, etc. Our recommendation for slide gates is to go with photo eyes. The reason being that most of the installations that we're involved with have a lot of radio frequency traffic, RF, and those wireless gate edges can cause havoc with that kind of thing. So just to get around that, we recommend using photo eyes for both open and closed direction, and then putting either some material in here or a hardwired gate edge if there's an entrapment zone that exists between the gate and the fence line. For swing gates, as I mentioned, it's only required to protect the closed direction unless there's an entrapment zone in the open direction. In which case, if there is, then you'd want to put a photo eye in that zone. Additionally, if you're putting the hinge point on a swing gate on some kind of a pilaster like this, you want to be concerned with where that hinge point is located. So if the distance is greater than 4 inches but less than 16, entrapment protection is required. So really the best way to approach this is just to make sure you move that hinge point so it's less than 4 inches. One before operate is built into all operators, but it used to be required as part of the standard, is no longer. However, it's a really good idea to continue with that. It is something you can disable. If you're in an HOA facility where that's going to be annoyance, it can certainly be turned off. And this lovely sign, there's 2 of these that ship out with every operator. It doesn't matter which operator company you're working with. It's this exact sign that's shipping out. These are driven by UL 325. It's the first thing that an attorney is going to point to if somebody does get hurt in the gate system. They're going to ask were there any warning signs. So it's pretty important to make sure these are there. We train our installers to put them on both the public and secure side of the gate panel, take a picture and have the end user sign off that those were also applied. Anytime you automate a vehicular access point, pedestrian access, separate pedestrian access is required. So a lot of people are surprised by this. So we don't want pedestrians walking through the vehicle access point. It's not required to have a PED door for every automated access point. It just needs to be an obvious way for pedestrians to get in the facility without having to go through the vehicle access point. And hopefully this is obvious not to do this. Somebody has built a pedestrian door into the gate and then supplied access control right there as you're walking through. So not a good idea. Couple examples of pedestrian doors installed correctly. And there is no standard that really says how far away the pedestrian door needs to be from the access point. So this one is perfectly fine, and they've done a good job of putting a sign on here. That's a great idea. So access control, as we mentioned before, that janitor leaving Dickey Stadium was able to reach through the gate and operate the gate while his arms are through the gate system. So the requirement here is that anything such as a card key system, a gooseneck, a keypad, anything that's going to be, require somebody to roll their window down, that needs to be no closer than 6 feet from the gate system, 360 degrees around the gate system. So that includes both ingress and egress, right? Can be further away, but no closer than 6 feet. And we're trying to reduce or mitigate the likelihood of this happening. Couple examples here. The one on the left is certainly in the right location. The one on the right is obviously a little too close. And when it comes to barrier arms do not fall under the UL 325 safety standard unless a barrier arm is moving within 16 inches of a fixed object. So that could be a bollard, what have you, a fence line, you name it. If it's out in the open like this, there's no requirement for any additional safety devices other than Type-C inherent trapment sensor system that's built into the operator. However, I recommend people put photo eyes under their barrier arms if they can. It's just a belts and suspenders approach to it. And if you did so, you'd put it like this. You'd want to put the photo eye directly underneath the gate arm and provide protection there for anybody walking through that access point. You'll notice in this graphic that we're showing in-ground loops. Loops are for vehicles, whereas what we're talking about is safety for people. But loops are very important. You want to make sure you do have vehicle detection loops. If you don't have those, you likely hit the vehicle with your gate. So very, very good idea to make sure you're putting those in there. If you're not familiar with loops, just real quickly, what it is typically is a saw cut into the pavement. They'll put loop wire in here and they'll seal over the top of that. They'll run a conduit off the corner up into the operator, and those loop leads will terminate on a loop detector. This wire is creating an electromagnetic field 360 degrees around that wire. And so the vehicle being metal as it drives over that loop, it's detected and tells the gate operator that there's something in the way, don't go closed. Once the vehicle drives off, the loops retain their signal, and then the gate operator can move the gate closed, typically on a close timer. If you're ever specifying a barrier arm, just make sure you specify a good quality one with a bumper on the bottom. I like to comment on this photo. You'll notice that there is both an automated swing gate and a barrier arm here. Obviously, in this case, the system got an open command and everything went open at the same time, which is fine. But oftentimes what you'll do here is connect the two operators and sequence them. So in that case, the swing gate will go open. When it hits its open limit, it sends an open command to the barrier arm to let the vehicle through. So it's a form of traffic control, can also be a form of mitigating tailgating. All right, so that's UL 325. Let's jump into ASTM. ASTM standard that was established back in 2001, and it dovetails with UL 325. So anytime you're automating the vehicular access point, ASTM F2200 comes into play just as much as UL 325 does. You'll find that most gate manufacturers are going to build their gates in compliance with the standard, but oftentimes there's going to need to be some customization to the gate to maintain compliance. So ASTM defines an entrapment zone as a space between any part of a moving gate and a stationary object. So when that space is within 16 inches, but greater than 2¼ the standard considers that to be an entrapment zone. So we're talking about this gap here. So this being the fence line, the slide gate operator. This is the gap we're measuring. So if that's within 16 inches, but greater than 2¼ inches, it's considered an entrapment zone. So you can do two things. As I mentioned, you could put some filler material in like the show here and bring that gap down to 2¼ inches. Or you could install a hardware gate edge on that guidepost. So a couple examples here, the gap without filler is 5 inches. They brought it down to 1¼ This one's already 2¼ so that's compliant with the standard. So you get the idea. So the one on the right is out of compliance. The one on the left is likely within compliance at 2¼ You see in this example, they did a good job of screening off here, but providing this is within 16 inches, they should have put some screening in here as well. And obviously you have to cut out a notch for the slide gate rail, but that one should have been covered as well. Follower protection. So we talked about that slide gate that fell over and hit that kid. If they had proper follower protection, that would not have happened. You can utilize an all-over design like you see here. That's fully compliant. Typically, you'll see something like this. But basically what you're looking for is to make sure that the gate, if it becomes detached from the operator, cannot fall over more than 45 degrees. So this is a great example of it done properly. You can see through the entire travel of this gate panel that their follower protection is applied all the way through. When it comes to swing gates, I've mentioned this earlier, you're only required to protect the closed direction unless there's an entrapment zone in the open direction. So if this gate in the fully open position is over 16 inches or at or over 16 inches, it's free and clear, no issues. If it's within 16 inches between the fence line and that gate panel, then you want to put a photo eye in that zone as well as a photo eye across for the closed direction. Swing gates, you want to make sure that you're utilizing a rounded gate edge as opposed to one that would be used for a slide gate. This is, of course, the reason being that the gate panel is going to sweep, and you want to be able to detect in multiple directions. So it's important that the entire gate comply with ASTM and reach through requirements. The standard requires a minimum of 2¼ inch spacing between pickets or any open area from the bottom of the gate up to 6 feet on the gate panel. So in a case of a picket style gate like you see here, oftentimes they will be constructed with these pickets at 4 inches on center, or they could manufacture it like this as well, which is compliant, and these would be at 2¼ Anything above 6 feet is fine at 4 inches on center. Below, up from grade up to 6 feet, no gap in the gate can be greater than 2¼ inches. So if you're working with a gate panel that is at 4 inches on center, a lot of times people will put some kind of fabric or expanded metal in there that's going to take care of this requirement. You want to make sure that the back frame on the gate panel is also covered. Oftentimes that gets missed. People are trying to reduce weight and materials and cost, basically cut corners. So you want to make sure you're covering that. The old standard used to be up to 4 feet on the gate panel. It's now up to 6 feet. And again, you want to make sure you're covering that back space, right? Additionally, The fence line that the gate panel is traveling across also needs to be covered up to 6 feet. So if this is a 30-foot gate, 30 feet of that fence line needs to be applied with some sort of material that brings that down to 2 1/4. So this is just an example of a couple of things that worked done to be compliant with the standard. One of them is the gaps. So nothing was done to address the gaps. They could have put some kind of expanded metal material or some kind of fabric on here to reduce those gaps. Access control point is likely, you know, maybe a little close, hard to tell with this. And there's also no signage on this gate. A couple examples here, obviously the access control being too close, that needs to be out 6 feet. And then you've got gaps here that need to be addressed. My approach on this would be to put probably a hardwired gate edge here, and then provide some material to bring this gap down to 2 1/4 on these two gaps. So when we're talking about slide gates, there's basically two types. There's cantilever and there's ground track. Ground track, otherwise known as V-track, rolling gate, you name it. People have a bunch of different ways of using terminology for that gate. Cantilever style, what you're showing here is a type 1 cantilever. The tail is being held up by these 4 wheels, and of course it's hovering across the lane as it opens and closes. And there's also a type 2 where the gate panel is basically hanging from a C channel, kind of like a closet door. Both will work. The type 2 is just a little bit higher end, a little more higher quality. But I do recommend cantilever slide gates in most cases if you can. You don't have issues with grade and that kind of thing. It's just a lot easier install and less maintenance. However, you are limited to 30-foot clear opening. Once you get over that, you're typically going to go to a V-track or ground track gate. When it comes to V-tracks, as I mentioned, you typically want to go here if you're going over 30 feet in terms of clear opening. What that is basically a concrete strip with upside down angle iron and a V-shaped wheel riding on that track. And typically used for much larger, heavier, wider gates. But there is some maintenance involved here. The track can come up over time. The gate can jump track. There can also be debris that causes issues with the wheels. And this is all kind of a unique one. ASTM requires that the gate panel cannot move under its own gravity if it becomes detached from the gate operator. So this is really more of an issue with ground track, V-track gates than it is with the cantilever. Cantilever, of course, is just going to fall down and, you know, rest up against the fallover post. So not a lot of great solutions here. Obviously, the most obvious one is that if you can regrade the area and get it more level, then you're good to go. But the bottom line is the gate cannot move under its own gravity if detached. It is required that all type 1 cantilever wheels are covered unless they are above 8 feet. So if they're over 8 feet, you're good to go. If they're below 8 feet, you do want to make sure you're providing covers. And of course, that also includes the guide rollers as well. And also your V-track wheels. So gate protrusions, you know, are punctured hazard when a gate hits a person or in either direction. So what's not okay on this is gate hardware, such as chain adjustment bolts that extend past 1/2 inch. Anything extending on both the side and bottom of the gate panel has to be cut back to 1/2 inch. Can't be any greater than 1/2 inch. The pickets coming out of the top of the gate are fine as long as they're in line with the gate. At 7 feet, they can curve over. So you see those gates with the pickets curling over at the top. It's got to be 7 feet before it does that. So leading gate edge, trailing edge, gate receiver guides, etc. So what is acceptable? As I mentioned, the pickets can be in line with the gate. The top pickets can curl over at 7 feet. Safety devices such as gate edges, of course, wheels supporting ground track, gate locks, positive stops are okay. So this is a common installation error when installing a chain-driven operator. So this bracket should be located on the inside of the post, and the bolt should not extend past ½ inch past the post. And then additionally, the vertical post shouldn't extend below the horizontal rail more than 4 inches. I'm sorry, ½ inch. So this all should be cut back ½ inch. When it comes to barbed wire, the gate panel must be a minimum of 6 feet. And then when it comes to razor wire, that's a minimum of 8 feet in terms of height. So the example on the left meets requirement for barbed wire. The example on the right is likely a little too short for razor wire. It's hard to tell there, but that's likely not 8 feet. And then ASTM also requires positive stops. So again, if the gate becomes detached from the operator, and again, this is really more of an issue with ground track gates, you want to make sure there's a positive stop, so it's stopping the gate from going down a parking lot and hitting the vehicle or somebody. And it's a good example of a positive stop on a V-track. So this graphic, this is another document that will be sent out. This graphic covers the entire presentation. So just looking at this, you've got everything we talked about. You've got your access control at 6 feet. You got your pedestrian access, separate pedestrian access. You've got your positive stops. You've got your follower post, your signage, your gaps brought down to 2¼ inches. Your gate edges on the leading and trailing edge. You've got your gate, your photo eyes covering both open and closed direction. And we'll also have one for swing gates. And this covers all the issues for swing gates. One thing to note on a swing gate, especially if you're using a pad mounted swing gate like this, I mentioned the 16-inch zone. It's when you're working with this kind of a gate operator, it's this knuckle that you're actually measuring. So as that opens, that gate opens, that knuckle is going to come towards this fence line. So you're measuring between that knuckle and that fence line. If that's within 16 inches, then it's going to require a photo eye. All right, so that's the end of the UL portion. I'll jump into the last couple of minutes here and cover our products just real high level. What we're showing here is our new SmartTouch 725 control board built into the operator. This provides a lot of functionality. As you can see, all the different devices that could be attached. These are your loop detectors I mentioned. Here's your loop, and then your leads are coming up and terminating on a loop detector. You've got your UL 325 photo eyes. This is an example of a receiver for a remote style clicker. But of course, any kind of access control can be applied here. All we need is a dry contact input from whatever it is, whether it's a keypad or a card key system. It doesn't matter to us. We just need a dry contact input. And then you've got your edge sensor here. This would be an additional photo eye that maybe is used in replacement of loops, that kind of thing. And then, of course, we have contacts for if you're using blue bus style photo eyes as well. This board has lots of functionality. You can set up to do simple primary and secondary programming. By that, what we mean there is that you can set up, let's say you have 2 slide gates meeting in the middle, what we call biparting. And so you have 2 gate operators. They're connected, they're networked together. They're set up as primary and secondary. They can share loops with the primary, that kind of thing. When it gets an open command, both gates go open at the same time. You can also set up Sally port configurations. Vehicle drives through, the gate closes behind the vehicle. The gate past the vehicle can't open until that gate behind the vehicle is fully closed. We can do sequencing, as I mentioned before, situations like, let's say you have a barrier arm in conjunction with a swing or a slide gate. You can set it up so that the slide or swing gate have to hit their open limit before the barrier arm then goes open. I mentioned the dry contact inputs and your loop detectors. Another thing too that this board offers is the ability to connect over any web-based device and do diagnostics. pull the fault log. In other words, if you're a maintenance personnel, you'd be able to see what kind of parts need to bring out to fix the operator, to do any kind of maintenance on the operator. We can do software updates with this as well. And we can also set up email and text alerts. So these could go out to certain maintenance personnel with some kind of an issue with the operator. We would tell them what's going on, and they'd be able to, again, pull that fault log and see what's happening. So we cover residential, commercial, industrial, and hostile vehicle mitigation, otherwise known as crash-rated barriers. I won't go into the residential. I'll start with commercial. So we have commercial operators that are electromechanical 24-volt DC operators. These are typically competing directly with companies like LiftMaster, Door King, that kind of thing. Your standard chain-driven slide gate operator, Slide Smart DC, take up to 1,300-pound gate panel, and then our Slide Smart HD will take up to a 3,000-pound gate panel. And in your standard pad-mounted swing gate, you'll see these on HOA facilities, typically in a bipartisan scenario like you see in that photo. These will take up to also a 1,300-pound gate panel per leaf, and oftentimes are in conjunction with maybe a barrier arm, that kind of thing. And then we've got air traffic control barrier arm, strong arm part DC. That's got an arm that'll go out a maximum of 14 feet. If you need to go longer, we have that covered in our industrial line. So our industrial operators are continuous duty. They're hydraulically driven. They contain fewer moving parts so that you'll see greater reliability in these. We like to measure their lifespan in decades versus years. So these things, we've seen them in play for 20 plus years and still going strong. And you'll find these specified in UL class 3 and 4 sites typically. If critical infrastructure such as DOD, petrochemical, substations, fire, police, you name it, those kinds of installations. Our slide driver offers speeds up to 3 feet per second in class 3 and 4 sites. And we'll move up to a 20,000-pound gate panel at 1 foot per second with the slide driver 200 there. Hydro swing, we like to call this a linear actuator on steroids. It'll automate up to a 40-foot gate weighing 15,000 pounds. It can withstand heavy wind loads. So wind loading is the enemy of swing gates. So this is an operator that can address that issue. The swing riser there, it's kind of a unique animal. It'll raise the gate panel straight up 4 inches, pulling the locking pins out of the ground, and then continues to raise another 8 inches for a full 1 foot rise as it opens to get up over curbs or if you have a grade issue behind the gate. That'll take up to a 3,000-pound gate panel. And the strong arm, that can go a maximum of 36 feet, covering multiple lanes at once. And then the Hydrolift, if you can't swing or slide, you can go straight up with your gate panel. That'll move 80 foot wide, maximum 2,000-pound gate panel, 16 feet in the air in about 8 seconds. And we also offer a complete suite of hostile vehicle mitigation barriers, otherwise known as crash barriers. These are typically specified in critical infrastructure, DOD, petrochem, state, federal, you name it. These are engineered and field crash tested to ASTM, IWA, and PASS certification standards. A strong arm M30, M50, those barriers will stop a 15,000-pound vehicle doing either 30 miles an hour or 50 miles an hour. Your Wedge Smart is essentially your strong arm park traffic control arm integrated in a crash wedge. So it's engineer rated to FS30, which means it'll stop a full-size sedan traveling at 30 miles an hour. And then our big boy, the Hydro Wedge SM50, and that is 15,000-pound vehicle doing 50 miles an hour. Typically, what you'll see is something like the strong arm out at the perimeter, and then something like a wedge further into the facility as a final denial barrier. And then we have our field crash tested bollards. We have both fixed, removable, and active bollards. Obviously, your fixed are alongside of the road. The active are going to be in the lane. People are typically choosing these for their aesthetics and the ability to allow pedestrians to kind of traverse through. Yeah, that's pretty much it on the bollards. And then we also have our strong slides. So We have a crash slide gate system. This is going to be the slide gate panel. Apologize for my landscaper. Make a little bit of noise here. So the Strong Slide is a full system. It includes the gate operator and the slide gate panel. You can see there's no infill there. It's because that's an open option. We can provide whatever infill you have. We have a bunch of infill as well. I'll give you an idea how these get tested in the field. We go to Carco in California and perform these tests. This is the Strong Arm M30. Again, it's stopping a 15,000-pound vehicle doing 30 miles an hour. You'll see here, we're actually measuring the back of the cab, how far into the secure zone it goes. This stick right here is a P1. There's P1, P2, and P3. So you can see that actually made a P1 certification on that crash test. And we had a little issue here just a few months ago. There was a auto dealership that would keep thousands of cars in a very large area for storage. And what criminals will typically do is they'll go in and steal a large truck and run it through the gate, and then they'll go back and steal the rest of the vehicles and just drive it through. So we actually mitigated that. They tried twice and didn't get through, and that was the Strong Arm M30 right there. So check us out on all of our social medias. If you go to our website, check out our support center. That's going to be your best friend in terms of getting access to cut sheets, installation guides, etc. And then our specification sales team, I handle the Western region. David Ward handles the Eastern, and Nikki Denno handles the Central region. So again, use us as your subject matter expert. We can talk to you about gate design, recommend the appropriate operator, consult with you on these safety standards, etc. So we can cover the gamut for you. Let us know if you have any questions on future projects. So that's it, folks. Appreciate it. Any questions?
There are a few, yeah. So what we will do is just go until the end of the hour if you will have us. And I can just go through the questions in chronological order. So beginning at around 12:05, the first question was, if we're working on a custom design gate, how do you recommend we make sure the fabricator meets these ASTM standards?
Yeah, well, in a lot of cases, they may not. You'd have to ask them, alert them to it, ask if they can design it to the standard. Oftentimes that's going to add weight and material and cost to it. So sometimes maybe it's a better way to approach it by putting some kind of material on the gate once it's installed. And that the onus is on the installer at that point then to bring it up to ASTM standards and UL standards. I want to mention too on this slide, disregard that QR code. AIA California is handling all that for you, so please don't scan that.
Yes, it'll be under AIA California's providers, so it may not work if you scan that. So don't worry, we'll submit your one AIA LU HSW for you. Thanks for mentioning that, Brad. So the second question for fire truck ladder access, is there specified to design swing gate, slide gate, or lift gate?
Either one's going to work for them. Their main issue is going to be how they get through the gate. So all of our gate operators are set up to provide contacts for either a Knox box or Tomar, Click Data, or there's a number of different technologies they might use. Regardless of what it is, we'll work with it. And you want to connect that specifically to the fire and emergency access dry contact on our board, in which case, if there's power, the gate will go open. And in this case, just FYI, it'll ignore all safeties, which is the way it's supposed to be. So, and the fire department comes through, it's going to go open regardless of any safety devices. If there's no power, then of course you want to make sure there's some sort of backup generation that's going to keep the operator moving. If all of that's dead, then there needs to be a way for the fire department to gain access manually, and we have those options for all of our operators.
Awesome. Let's see, next question. What is the field of view for the photo eye?
There are different ranges of, gosh, we can go, I think somewhat over 100 feet on some of them, but the typical range is like around 65 feet. But that list of our approved devices has a bunch of different options for different ranges.
Alrighty. Let's see. The next question, can you discuss issues around access systems that combine both gate arms and an access gate, like a roll-up door? Does UL 325 standards apply to the gate arm more than if the gate arm was a standalone?
So the UL 325 definitely applies to the gate arm. Roll up and garage doors do have a division within the standard, but it's separate. It's different than vehicle access. Gate operators. But I think I heard in their integration, so there can be ways to sequence, with something like a roll up door. Yes,
Okay.
a lot of times it's done with relays. Our control board does have user relays built in, so there's a lot of functionality there. Just know that there's a lot of capabilities related to sequencing, that kind of thing, built into the control board.
So the next question, I didn't see this in your presentation, but it was asking if you were going to be discussing roll-up gates. I'm not sure if you have any information on that or if high security or NICE do any of that, but maybe we can send
Yeah.
information out.
So high security does not. We're strictly gate operators, vehicle access gate operators. But there's a division of NICE that we do, in fact, have a large division that does garage doors and roll-up doors. So if whoever that is can contact me, I can certainly get them in touch with the right people.
Thank you. So let's see, fall over protection. Visual showed the resting section of the fence. What technique is needed within the travel zone?
Can you repeat that? I'm sorry.
So for the fall over protection, the visual
Yeah.
showed the resting section of the fence. What technique is needed within the travel zone?
For fallover protection, really the standard, all it requires is that the gate cannot fall over more than 45 degrees if it becomes detached. And so you want to make sure that's the case throughout the entire travel of the gate panel. Hopefully that answered that.
All right, let's see. How do you prevent a gate from moving under the weight of its own gravity if detached from the system, if the gate is on a slope?
Yeah, that's a great question. Not a lot of great solutions that are other than regrading so that it can't do that. Other than that, that's pretty much it. I mean, you could, when we're talking slide gates, that's really the only thing that applies here, slide gates. You could use a cantilever gate in level position, but then that's, it's gonna have to go the right direction from the incline. But you could do that, and it would actually kind of be unsightly as it comes up over the fence line when it opens. But that's an option. It's not a great one, but the best thing is really to regrade and get it level so that it does not move under its own gravity.
Right. Relative to combined gate arms and roll-up doors, should all entrapment protection devices be interconnected with both devices pausing the combined system?
Well, that's a great question. Yes, the simple answer is yes to that. You definitely want to make sure that you have some way of identifying the vehicle in the way. And in the case of roll-up doors, we'd have to know which one it is and how they operate in terms of how we would integrate and share loops. But it is possible.
All right, we have three more. I'm going to try and get them out. If an existing condo complex has a sliding gate but no man gate, is this a code violation?
Yeah. You need some way for pedestrians to get into the facility without going through the vehicle access point.
Alrighty. How do you account for the 2.25 max reach through for double panel sliding gates?
Double panel sliding gates, I'm assuming we're talking about a biparting situation, and both panels need to be addressed in terms of the 2¼ inch. I think they may be referring to the gap between the two gates when they come together. I'm not sure, but that gap should be down to 2¼ inches as well. But typically the installer is going to set those so they're virtually almost touching. When they come to a stop, the gate operator has a limit, open and a close limit. So they'll set that close limit so that they just come right together.
Alrighty, last one is, do you have any shipping Dropbox add-on features? I'm guessing they're talking about your stock.
Shipping Dropbox.
Yeah, so I think probably, I'm assuming, like some security boxes for those porch pirates that we all have, those types of things within your gates.
Oh, no, we don't. It's an interesting question. So I'm assuming they're asking if that's going to provide some sort of access to delivery people.
Probably.
Yeah. That's just going to be a matter of the access control and how that addresses it. It really depends on what access control is being utilized. We don't have anything specific to that. It's a quick answer.
Okay. Well, that is it on the questions, and that is it on the time. So I want to thank you, Brad.
Okay.
We got through all those questions very quick, so thank you for allowing time